You are watching AliAziz Quality Education YouTube channel.
Gas Turbine Engine I in BSc Aircraft Maintenance Engineering Technology, AMET, by AliAziz Quality Education.
AliAziz Quality Education channel, providing you the aviation industry related videos, so don't forget the subscription button.
The gas turbine engine is the primary propulsion system used in modern commercial and military aircraft. It delivers high thrust, efficiency at high speeds, and reliability over long distances compared to piston engines. The subject Gas Turbine Engine I in AMET introduces students to the fundamentals of gas turbine operation, components, and basic systems. This module provides a foundation for understanding how turbines generate thrust and prepares students for more advanced studies in Gas Turbine Engine II. Objectives of subject Gas Turbine Engine I. To understand the basic principles of gas turbine operation. To study the thermodynamic cycles that govern turbine performance. To identify the main components of a gas turbine engine and their functions. To learn the types of gas turbine engines used in aviation. To introduce basic maintenance and safety practices. Main topics covered. 1. Fundamentals of gas turbine operation. Comparison of piston versus gas turbine engines. Brayton cycle, constant pressure cycle, and thermodynamics. Energy conversion, chemical thermal-mechanical thrust. Factors affecting thrust, mass airflow, temperature, pressure, speed. 2. Types of gas turbine engines. Turbojet, simple design, high-speed performance. Turbofan, most common in commercial aircraft, high bypass and low bypass. Turboprop, efficient at low and medium speeds, used in regional aircraft. Turboshaft, used in helicopters and auxiliary power units, APUs. 3. Major components. Air intake system, directing smooth airflow into the engine. Compressor section, axial and centrifugal compressors, pressure ratios. Combustion chamber, fuel-air mixing and ignition. Turbine section, power extraction to drive the compressor. Exhaust system, acceleration of gases to produce thrust. 4. Supporting systems, introduction. Fuel system, fuel pumps, nozzles, and metering. Lubrication system, oil pumps, filters, and cooling. Ignition system, high-energy igniters. Starting system, electric, pneumatic, or hydraulic starters. 5. Performance and efficiency. Thrust measurement and specific fuel consumption, SFC. Effect of altitude and speed on engine performance. Thrust augmentation methods, afterburner, water/methanol injection, basics. 6. Maintenance and safety. Engine inspection routines, pre-flight, borescope. Common defects, compressor blade damage, turbine blade overheating, fuel leaks. Importance of foreign object damage, FOD, prevention. Basic regulatory compliance, EASA/FAA standards. Importance for AMET students. Provides a strong foundation in jet engine theory and operation. Helps in understanding the transition from piston engines to turbines. Prepares students for advanced study in Gas Turbine Engine II. Essential for EASA Part 66B 1.1 license and professional maintenance exams. Career relevance. Students with knowledge of gas turbine engines can work as aircraft maintenance engineers, B1.1, turbine aeroplanes. Engine overhaul and repair technicians. Power plant engineers in MRO organizations. Performance monitoring engineers in airlines. Conclusion. Gas Turbine Engine I introduces AMET students to the principles, types, and core components of turbine engines. It provides the essential knowledge required to maintain and troubleshoot modern aircraft propulsion systems, laying the groundwork for advanced study in Gas Turbine Engine II.